Hello scholars and welcome back to the channel. In today's video, we're taking a deep dive into one of the most critical aspects of any research endeavor, sampling methods and techniques. Whether you're a budding student or a seasoned researcher, truly understanding how to select your study participants is paramount for producing credible, reliable, and generalizable research results. If you're new here, remember to like, share, and subscribe for more insightful content. Let's ensure your next study stands on a solid foundation. What is sampling and why is it essential? At its core, sampling is the process of strategically selecting a subset or sample from a larger population that you wish to study. Why do we do this? Imagine trying to survey every single patient in a hospital with 5,000 beds about their satisfaction. It's often impractical, prohibitively expensive, and sometimes even impossible to gather data from an entire population. So researchers use samples to draw conclusions that can then be generalized back to that whole group. Think of it this way. You want to know how a large pot of soup tastes. You don't need to drink the entire pot. A well-stirred spoonful gives you a good idea. That spoonful is your sample. Sampling is essential because it offers significant advantages. First off, it's time-saving. Collecting data from fewer individuals is, well, much faster. Then there's the cost-effectiveness. Less data collection means fewer resources spent, which is always a good thing. It's also about feasibility. Sampling makes those large-scale research projects manageable, and lastly, enhanced data quality. With fewer participants, you can often collect more detailed and accurate data from each. However, the way you select your sample critically impacts the accuracy and reliability of your findings. A poorly chosen sample can lead to biased or inaccurate results, which is not what we want. On the other hand, a well-chosen sample provides reliable insights that genuinely represent the entire population. This allows you to confidently generalize your findings, which is what good research is all about. Types of sampling methods, the two pillars. Sampling methods are broadly categorized into two fundamental types. These are distinguished by how participants are selected and the generalizability of the results. First, we have probability sampling, and then there's non-probability sampling. Let's break down each one, shall we? Probability sampling, the foundation of generalizability. Probability sampling methods are the gold standard when your goal is to generalize your research findings from your sample back to the larger population. Why? Because in probability sampling, every single member of the population has an equal chance of being selected into your sample. This crucial characteristic significantly reduces selection bias and makes your results statistically defensible and generalizable. Let's explore the key techniques within this category, simple random sampling. Simple random sampling is the most basic form of probability sampling. Here, every individual in your defined population has an entirely equal and independent chance of being selected. It's like a true lottery where every ticket has the same shot. This method effectively minimizes selection bias, making it highly desirable for maximizing the external validity of your findings. How it works? You need a complete list of every member of your population. This is called a sampling frame. Then you use a random selection process. Example 1. Balloting or lottery method. Imagine you're studying job satisfaction among all 300 nurses in a large hospital. You could write each nurse's name on a slip of paper, place them all into a container, mix them thoroughly, and then randomly draw out, say, 50 names for your sample. Every nurse has an equal chance of being picked. Example 2. Random number generator. More commonly in modern research, if you have a digital list of all 300 nurses, you'd assign each a unique number. Then you'd use a computer-based random number generator or statistical software to randomly select 50 numbers. The nurses corresponding to those numbers form your sample. This is often more efficient and less prone to human error than physical methods. Stratified sampling. Stratified sampling is used when you want to ensure specific subgroups or strata within your population are adequately represented in your sample. You first divide your entire population into these distinct, non-overlapping subgroups based on relevant characteristics. For example, age groups, gender, socioeconomic status, professional roles, or disease severity. Once these strata are defined, you then perform simple random sampling within each stratum. The power of stratification. It guarantees representation of key subgroups, which might otherwise be missed or underrepresented in a simple random sample, especially if they are small within the overall population. It allows for more precise estimates for each subgroup, as well as for the overall population. Example, suppose you're researching burnout among nurses and believe gender might play a role. Your hospital has 300 nurses, 240 females and 60 males. A simple random sample of 50 nurses might by chance select very few males, making it difficult to analyze gender differences. Using stratified sampling, you would 1. Create 2 strata, female nurses and male nurses. 2. Decide on your sample size, say 50 nurses. 3. Proportional allocation. If you want your sample to reflect the population's gender ratio, you'd randomly select 40 female nurses, 240 divided by 300 times 50 equals 40, and 10 male nurses, 60 divided by 300 times 50 equals 10, from their respective strata. 4. Disproportionate allocation, optional. If your research specifically aims to compare male and female experiences, you might decide to randomly select 25 male nurses and 25 female nurses, even though it doesn't match the population proportion. This ensures enough data for subgroup analysis. Systematic sampling. Systematic sampling is a straightforward method used when you have a complete ordered list of your population. It involves selecting every nth individual from that list after a random starting point. How it works? First, determine your desired sample size. Then, calculate the sampling interval by dividing the total population size by the desired sample size. Next, randomly select a starting point between 1 and the sampling interval. Finally, select every nth individual from that starting point onwards. Example. Imagine a clinic wants to survey 50 patients from their admission log, which lists 500 patients in chronological order of admission. First, the population is 500, and the sample is 50. Next, the sampling interval is 500 divided by 50, which equals 10. Then, randomly choose a starting number between 1 and 10, let's say 7. You would then select the 7th patient, then the 17th, the 27th, and so on, until you reach your 50 participants. This method is efficient and easy to implement, but it's important to ensure there's no hidden pattern or periodicity in your list that could introduce bias. Cluster sampling. Cluster sampling is particularly useful when dealing with geographically dispersed populations or when a complete list of individuals is unavailable. Instead of sampling individuals, you divide the population into naturally occurring groups or clusters, like hospitals, schools, neighborhoods, or specific wards. You then randomly select entire clusters and collect data from every single member within those chosen clusters. Key distinctions. In stratified sampling, you sample from every subgroup. In cluster sampling, you sample entire subgroups. Example. Suppose you want to evaluate the implementation of a new patient handover protocol across a large healthcare system with 30 hospitals. Surveying individual nurses across all 30 hospitals would be very complex and costly. Using cluster sampling, you'd identify the 30 hospitals as your clusters. You would randomly select, say, 5 of these hospitals. Then you would collect data from all relevant nurses or departments, depending on your research, within those 5 selected hospitals. Multi-stage cluster sampling. For even larger areas, you might use a multi-stage approach. For example, first randomly select states, then randomly select counties within those states, then randomly select clinics within those counties, and finally survey all patients in the selected clinics. This is commonly used in large-scale public health surveys. Non-probability sampling, when generalizability is less of a priority. Non-probability sampling methods are typically used when the primary goal is not statistical generalization to a larger population, but rather to explore a specific phenomenon, develop hypotheses, or conduct pilot studies. In these methods, not every member of the population has an equal or known chance of being selected, which means they are more prone to selection bias. However, they are often more convenient, quicker, and less resource-intensive. Let's look at the common types. Convenience sampling. Convenience sampling is exactly what it sounds like. You select participants who are the easiest to reach or most readily available to you. This method is often employed in exploratory research, pilot studies, or when resources and time are severely limited. Example: if you're conducting a quick survey on patient satisfaction at a local clinic, you might simply approach the first 50 patients who walk into the waiting room on a given day. While easy to conduct, the results are less reliable for generalizing to all patients of the clinic, as those specific 50 might not represent the broader patient demographic or their experiences. Purposive or judgmental sampling. In purposive sampling, also known as judgmental sampling, you deliberately choose participants based on specific characteristics, expertise, or criteria that are directly relevant and important to your research question. You, as the researcher, use your judgment to select individuals whom you believe will provide the most insightful and useful information. Example: if your study focuses on understanding the practical challenges of implementing a new advanced life support protocol in the intensive care unit, you would purposively select experienced ICU nurses and physicians who have direct involvement with and knowledge of this specific protocol. Randomly sampling nurses from other departments would not yield the rich, relevant data you need for this specific inquiry. Snowball sampling is a method often used for hard-to-reach, hidden, or sensitive populations where a sampling frame doesn't exist. You start by identifying a few initial participants who fit your study criteria. After they participate, you then ask them to recommend other individuals who also meet the criteria and might be willing to participate. The sample size then snowballs as more referrals are made. Example: imagine you're studying the unique challenges and burnout experiences of nurses who exclusively work night shifts, a group that can be difficult to access directly through official lists. You might start by contacting one night shift nurse you know. After interviewing them, you'd ask if they could recommend other night shift nurses who might be willing to share their experiences. This method helps you gain access to a specific, often interconnected community. Thanks for watching, and see you next time.